the consequences, but they're trying to find the cause. Hippocrates comes into picture at this time. That's him trying to refuse lots of money from people who want to cure plagues in their city. That they're not from Greece. I forget which place they're from in current. It could be from Slovakia. I'm not sure. And other regions. Hippocrates then goes and cures the plague by taking out the bad air in Greek cities. Following this, it's largely fictionalized. This picture is from a fictionalized tale about Hippocrates. But Hippocrates did write a text called the Hippocratic Corpus, from which the Hippocratic Oath comes, and he, in order to get to the causal mechanisms, he started to actually examine his patients, and he starts using these terms that we still use today, well, translated into English: exacerbation, relapse, resolution, crisis, peak. Those are all terms that people or doctors use for disease states. So that's something. But while they were trying to find causes and getting it wildly wrong, and also dealing with the consequences of aging, the thinking in ancient Greece, everybody here probably knows that. Everybody here in this room probably has better classical education than I do. I was in public school in the US, so none. Because we know about the tale of Prometheus, everybody here knows that. Prometheus stole fire from the gods, gave it to us, and gods punished him by chaining him to a cliff. But the gods also punished the humans by giving us death and decay. Tithonus, the tale where this goddess falls in love with him and asks Zeus to make him immortal, and forgets to ask him that he shouldn't grow old. So he gets older and older, more and more decrepit, and then he finally turns into a cricket. I don't understand, but okay. And then he's put in a cage, or she puts him in a cage, which is logical. But so that's the background. That's the thinking. Again, very apologist. Okay, and everybody will tell you this. Now, when you guys go to an aging talk next, the much better versions of what I'm giving, and about new technology, look at the questions that come up at the end of the talk. Listen to what people ask. They may not know these philosophies, but they are actually espousing the same terminology. Because death is, or old age, or lifespan is always associated with decline in health. It is one and one. Nobody thinks of lifespan with good health. They always think of Tithonus. They may not know the name, or Tithonus. But even I don't know the name. But they always think of this logic system. Somehow it's permeated, whether you know Tithonus or not. So that's our little tour. I don't want to talk about the Romans. They didn't do anything except give us the term YOLO or carpe diem. They didn't expand on the medical text or the philosophies or the thinking as I'm talking about beyond what the Greeks did. So instead, I move on to somewhere cooler. You know what I should have done is have that Indiana Jones thing with the plane going from place to place. That would have been good. So China is pretty cool because so this is around the time when the Greek philosophers were doing their thing and everybody knows about them. But Gi Hong, I'm probably butchering the name, and if anybody understands Chinese here, that's wrong way, wrong side up, because it should be here, but I couldn't fit it, and it still looks cool. So I'm sorry. Just twist your head if you can read Chinese. But what I wanted to say is that Gi Hong, philosopher and a politician, a prominent politician, in China around the same time the Greek philosophers were doing their thing, points out what I want to. What he says is, so he falls in love with science, whatever science is there at that time, and he thinks that can actually solve aging or can help us achieve immortality. He says, we may perhaps be unable to make up our minds to believe that our lives can be prolonged or that immortality can be obtained, but why are we reluctant to make a trial? If only a slight success should come from this trial, gaining thereby only 1 2 or 3 centuries of life, would even this not be better than early death of the masses? So he's the first, at least the philosopher that I know of, that makes this claim. And there are others in India as well, although India wasn't one united country then, that say similar things with more religious tones, although this guy is a Taoist as well. Make no mistake, there are other people who are saying same things that the Greeks are saying in China at that time, but I'm just giving you the biggest voice in different places at the time. So that's what the Chinese philosophy was around that time towards mortality and aging. This is the first prolongist that you're meeting. Before this, everything has been apologists. And the treatment that Chinese medicine uses, again, is interesting, is very similar to what Greeks and Egyptians and Babylonians and Sumerians were doing, observing the patients and then treating it with their own herbal medicine, for lack of a better word. Again, failing miserably. Chinese medicine also had causal agents, kind of like the Greek humoral things, but they were more associated with, they were also associated with balance, but they were balanced with the energy force with the universe. I don't understand much of it, so I haven't put it. It was very much influenced by the Tao philosophy. All right, so we move back in Europe. So this is the last bit of religious or pseudo-religious history. So in Hebrew mythology and the Judeo-Christian mythology, we're coming now to very much, again, you see the motive of having access to immortality in the Garden of Eden, trying to get access to knowledge, and then somebody, a father figure or somebody, in this case God, getting mad and Adam losing his place because he tried to access knowledge that was beyond his reach and losing immortality and so forth. So that was very much a thinking of that time. And because we have already told you the story of Gilgamesh, you see this again in the Hebrew texts in Europe. Now, this is a little while later. We are still in Europe. Western civilization is dominating the world, and now we're in Cambridge. So, at this point of time in Cambridge, the thought process is being dominated by the apologists, just like mentioned in the Hebrew text, the Bible. So it's very hard to be a prolongivist in this area. To think that humans can and should live longer is, yes, it's committing a moral sin, because God doesn't want us to. So in this backdrop comes this Christopher Marlowe. He's an English graduate from Cambridge, and then gets his master's and writes his first play. Again, notice how this motive, whether or not you're from a US public school and don't know about Greek philosophy or Christopher Marlowe, the themes go through society, and you know this. So you may not have read this, most people, I don't know if they have, but the Faustian bargain, that word may ring. So this is what Christopher Marlowe writes, which seals the deal for pretty much apologists until now, for pretty much the rest of time up to now. And in his story about Dr. Faustus, this guy, Faustus, the scene 1, act 1 opens with Faustus sitting in his chair and thinking, what problem should he solve? By the way, I was narrating this story to my partner because I was practicing this talk, and she listened to it, and she said, it sounds exactly like you. So I don't know what that says. So Faustus is sitting in his chair trying to think of a problem that he can solve because he thinks he's better than everybody else. That's the problem with long-term relationships. And he thinks that he should be a physician because then he can help people. And he thinks, no, that's too short, that's too small. Then he thinks, well, I could cure like epidemics and like help whole cities and stuff. And he's like, well, there are physicians already doing that. So what is bigger than that? And he thinks of there's one thing that we couldn't achieve, which is immortality. Now, if I could solve immortality, that's a goal worth my stature. Like that is something I should tackle. So he says, well, how do I do that? And he goes and makes the deal with the devil, as you guys probably know, or culturally have heard about. He gives his soul to achieve knowledge, and through knowledge power, and he achieves immortality, except the devil comes and takes him to hell, so he's immortal in hell. And so that kind of seals the deal, and that story kind of goes through, through time, and that pretty much sets the scene for eternity as to why somebody would want to live longer. Fortunately, again in Cambridge, but this time a lawyer instead of an English major, we have Francis Bacon. Now, I want to read some of the stuff. So Francis Bacon comes out and he publishes. Actually, he tries to publish, but he couldn't get his Valerius Terminus published. And the whole goal of the Valerius Terminus was to understand nature well enough to achieve immortality. He tries to say, he is a product of his time, Francis Bacon, and what he's seeing happen in the world around him, where the whole world is being mapped, the whole world is being explored, and we are finding new technology, we're finding new techniques of mining. What he wants everybody to do in his society is to do that to find immortality. So he wants everybody to stop reading scripture, to stop reading Greek medical texts, and actually start doing experimentation. So remember, this is Francis Bacon, who pretty much, after Copernicus, started the scientific revolution that we have today. So he writes lots of texts, including this, but since his text where he wrote about immortality is not published, well, until recently, I didn't put up that picture. So he's asking everyone that everyone should try to do research in all of these areas, because immortality or aging is a solvable problem. I don't know why he thinks that, because we still haven't come across any of the causal agent. People are still dealing with the consequences, but he thinks that it's doable. And he lays out a completely roundabout way of thinking. He thinks that we had access to knowledge in the Garden of Eden, we lost it, and then all that's remaining is to find that knowledge, and then we'll be back to square one, which we will be immortal. So his interpretation of scripture is slightly different. So he's pushing everybody. So he's the first one calling for dissection of bodies of dead people. He's the first one calling for randomized, well, not really randomized control trial, but at least trial for testing things out. And this is Francis Bacon. And he is definitely a prolongivist through and through. All right. So now we have come to pretty much the world as we know it, like the 19th century, 20th century. So Darwin is present, and so is his good supporter August Weismann. And Weismann lays out his arguments for death. So let me just, I could sum up Weismann's argument in one sentence. The immortality of protozoa is primitive compared to the mortality of metazoas like us. Weismann's argument that he lays out, and it dominates biology for a very long time, is that death evolved, and it evolved to keep healthy populations alive. It is a species-level evolution, as in, for the good of the species, they all must die. We tell that to retired people, because they need to, because young people have access to jobs, whatever. He didn't say that. I'm making that up. But really, I mean, in nature, they need to have access to stuff. He says that to that sentence that I read you, he says that only primitive life, the single cell life, they don't have anything else to do but to divide and divide. They're not complex. Seems to have a great disdain for single cell life. But the immortality of protozoa is primitive compared to the mortality of metazoa, like us. He points out that if we just kept living longer and longer, and if we were immortal, we would get infirm because of accidents or, I don't know, rays from the sun. And what would happen? We would not have much space on the planet. So death evolved in order to kill the old people. That was his hypothesis in not so many words, a lot more words. So this motif, again, you will hear again and again in society, where people think that death is just like any other mechanism. It evolved over time in order to kill the old. Still dominates some discussions. And here comes Peter Medawar. Now we're firmly in the time that we live in. So Peter Medawar won the Nobel Prize for his work in immunology during World War II, where he develops new methods for skin grafts. And he studied Weissman's old age arguments, and he says that it's completely wrong. And he says that it's completely wrong because death doesn't need to evolve. Because we are the exception in this room. No other species builds modeling colleges and doors and things. They don't. Nature happens. Nature is great at extinguishing life. There is no need for death mechanisms to evolve. The only thing that species have to decide is when and how quickly to reproduce. And the mutations that are selected for are selected in youth. It doesn't matter what happens when you are old, because you mostly don't survive to be old. So death mechanisms don't have to evolve because nature kills readily, all the time. There's no need for death mechanisms. And things that are selected, evolutionarily selected, are selected when you're young, because that's the time that it matters. Another term for this is antagonistic pleiotropy, which is used later, which means that genes that are selected to keep you awesome when you're young may have negative effects when you're old, but because we haven't weeded them out, because there was no mechanism to weed them out, there's no need, you would have been dead, they are now causing damage because we're living long. So Huntington's disease is an example of that. He uses that in his essays, why Huntington's disease has survived, because it can still get you till your reproductive age. Modi, which is a form of diabetes, is another version of that. These genetic diseases are a cause of that. So Medawar's arguments are, it's just that genes that cause progressive frailty do not matter in the wild. Genes that cause late onset diseases are invisible in nature. So it only matters if you're living long enough. So Medawar's arguments are then summarized and mathematized in the 1970s by British biologist Tom Crickwood. And here, you can see the maximal lifespans of different organisms. And that's really because they're balancing so he puts in the mathematical terms, Crickwood does, they're balancing how quickly should they reproduce, and that's basically it. So bodies aren't built to last. They're built to grow up fast. Or in other words, they're built to get to the point where they can reproduce. Many of you here have probably had or have a dog. How quickly does a dog reach reproductive age? If you have worked with mice in your lab or no, I mean, that's the whole point, is that you get to the point where you can reproduce and then you move on. I mean, you don't even have to move on because something will eat you or kill you in the wild. So animals that don't have predators or that can get away from predators, that basically is a rat. So that's not a rat, but that is just a flying rat. But it lives a lot longer than rat because it can get away from predators. So it can take time to mature. So it lives a little bit longer. So now we're about 10 or 20 years away from where we are currently, and so we are understanding now what is aging really. We're still in the hospital, still treating the outcome of aging, so the damage done by aging. We are finding causal agents, because at this time Richard Dahl, Richard Peto are working, and chimney boys have already happened, so we know a little bit about what causes cancer. We know that smoking is bad, so we're finding causal agents, but we're hitting and missing a lot, but we're getting there. Then this happens. This is a nifty little trick that happens in the 80s and the 90s, which is Methuselahs. So until this point, we have Weissman and we have Medawar, and everybody's arguing about evolutionary biology. And then there are two groups of biologists. There's the group of biologists that are making theories and writing papers, and then there are a group of biologists about this time and a little bit before that are doing work at the molecular level. And the molecular biologists consider the evolutionary biologists as stand collectors. And then the evolutionary biologists consider molecular biologists as basically, technicians, which is supposed to be either way pejorative in case you didn't get that. And at this point, both of them do different things to cause these organisms, for the first time that we know of in our history, to live extraordinarily long lives. This guy, C. elegans, the worm you may have heard about, we can extend their lives like 500-fold. It's just remarkable how much we can extend their life. Those guys, we can extend their lives significantly. Now, the two camps, the way they did it with the fruit fly and the worm is two ways. So you have Cynthia Kenyon, who received the Nobel Prize a couple of years ago for her work on telomere, adjusting genes, finding gene mutations, and then tweaking genes in the worms and making them live longer. And then you have another way is calorie restriction. You just give them less food, and you again make them live longer. Both the flies. So Michael Rose at this time is doing his fly experiments where he's giving them less food. The flies are turning off their reproduction facility. They're living longer. They're waiting for the day that they get a good amount of food to reproduce. And the older the fly is breeding, the next generation is more robust. You see the previous argument that the genes that are being selected for are then at least that good for that long. So if flies had Huntington's or whatever disease that killed them young, they would have died anyway. They would have died before reproduction. Only the flies that were living long enough to be able to reproduce under the calorie restriction regimen were able to go through. And you didn't even need calorie restriction. You could just force flies who lived that long to reproduce. So it could make a bench rule that only 50-year-old flies don't live 50 years, I'm just making up the numbers as humans. 50-year-old flies were allowed to reproduce. 50-year-old healthy flies were allowed to reproduce. Then the next generation is quite robust until 50, and then maybe you can push the age to 60, and so forth and so on. And that may be the mechanism that would be working in our societies over time, is that we remain healthy longer. Centenarians give birth to centenarian kids. The best way to become a centenarian today is to have parents who are centenarians and grandparents. It's the same thing with Nobel Prizes, actually. Not the parents part, but working in those labs that have won Nobel Prize. Okay, so that's zebrafish and that's mice. So again, the curious thing about this is that it doesn't hold. So I told you that we can increase the worm's life by a very, very long time. The flies by a significant amount, but not as long as the worms. As you get more complicated, we can't extend the lives that long. Remember, if you remember the logic of how quickly you build up to reproduction, and then, so the quicker you build up to reproduction, the less effort you're spending in building a better ship or a better organism. Because you just build up to reproduction and you die. Because there's no point. So dogs die much quicker than we do. So whereas elephants live a lot longer, but they take 30 years to come to maturity to have babies. So that's the equation. Percentage of life you spend in getting to the point where you can have babies. If that's larger, then you have less room for expansion in the end. because you're already built quite nicely. Whereas if that percentage is shorter, is smaller, then you have lots of room for improvement by scientists in the lab. So we find progressively less benefit with the same genes in these things. Next time you hear a story, take that into account. So what's happening in humans? This is what's happening in humans. England. This is England and Wales data, only from males. Females are actually better. So I just ignore females. So here is males. That's 100% of males surviving at birth, and then that's 0% of males surviving at 100. Okay. Now notice that there's a bottleneck here. People are only living up to, about 100. We'll come to that. But here, there's a lot of room for expansion. So look at this. About what? Should we call it 23% of British kids or English kids, English and Welsh kids were dying, males, by the time they were reaching like 2 or 3 years of age in 1860. You have preventative medicine called vaccines and antibiotics, and that's really all that makes the difference. And then you have between 1860 and 1960, you have that much increase. All of it comes because you don't have early life infection. You're robust in your early life. That means you're helping out that developmental period even more. So not only humans take longer time to develop compared to dogs, but also with antibiotics and vaccines you're helping out. So you're robust adults here. But then you do a nifty trick to make yourself less robust during your adult life by smoking, like a chimney. Like 75% of males smoked in England, like during World War II time. It's even more in America. And this shift, look at it. It just comes in adults. It just happens in adults. That happens because of reduction in smoking. That's how stark that effect is of smoking. It's just absolutely amazing. And that's just male data. So now what you have is about 80% of the males, or more than 80% of the males, almost 90% of the males surviving till at least 70. Now that's still a bad bottleneck, okay? So look at how steep the curve is. This is how we die. So that's, you remember 1900, that this, I'll just give you the shorthand. We used to die in 1900, but this is America data, previous was England, but it's really same. We used to die from infectious diseases, things that especially hurt you when you were a child. But now we mainly die of diseases of old age, cancer, diabetes, heart disease. So what we are left with now is aging. We really are left with aging. All those articles that you read about antibiotics running out, that is actually possibly true, and it's great to read those, but we don't know 99% of the bacterial kingdom, and probably 97% of the fungal kingdom. So there is enough antibacterial agents and antifungal agents out there. We just haven't looked for them. So don't worry about that so much. Let's worry about the problem that's at hand, which is cancer and heart disease and diabetes that is coming up, and Alzheimer's disease. So, that's terrible. All of this brings us down to 3 ways of curing aging, basically. If you could do all 3, you could cure aging. You could improve metabolism to reduce harmful byproducts. Remember, that's what we are doing with C. elegans, or the worms and the flies. We are helping them out, what they didn't do naturally. We are helping them improve their metabolism so that they don't have that much byproduct, the damaging byproduct, and they live substantially longer. In some cases, we also do this, which is clean up the damage generated by metabolism. So you eat, you live, you cause damage, and that we can clean up. Or we can deal with the products of damage. If we do all 3, we cure aging, or we can do one of these 3. We have been doing this for 4,500 years with different tools, the last part. And this is where we are. We are here with this bottleneck. This cannot be steeper. It just can't get any more. This ride, the ride that you take from there, that's quite a drastic ride, where you're waking up at 70 and you're like, holy crap, this is all the way down. And I mean, look at it. Look at a person who was in 1860 who reached at 70. They were at 70. Their ride is quite smooth comparatively. This is a fantastic roller coaster. Can you imagine if green tea or resveratrol or something pushed the median lifespan, which it wouldn't, but let's assume that it did, you would be here. So you'd be waking up on your 85th birthday and knowing that you're going to die tomorrow. So, but anyway, while all of this is happening, there is one curious fact that's in the backdrop, which is whatever your age and wherever you live on planet Earth, your mortality rate doubles every 8 years or so, from birth till death, period. And this curve is already so steep. So there is really nothing we can do besides trying to do the top two. Now, next time you hear a news story, I would highly recommend to put them in one of these categories. By the way, to give you a hint, it's either that or this. It's rarely that. Nobody is working on that. There are some companies making drugs for cleaning up Alzheimer's plaques in the brain, but that's quite rare. Mainly you will hear about calorie restriction, 2-day fasting, whatever the new fad is, I don't know. And that comes in here, which is trying to improve your metabolism. Good God, man. Your metabolism is as good as it's going to get if you're not smoking and don't have like terminal illness like morbidly obese or gluten allergy. You really should do nothing, because you're going to end up in this curve. And if anybody can tell you that they can change that figure that I told you, that your mortality rate doubles every 8 years or so, okay, they would have to give you a human trial that has at least run for 8 to 16 years with something that would define that kind of range. So like 20 million people. I don't know of any treatment that's out there that has done that work to show you that would actually affect your mortality curve. Now, I'm not talking about your personal allergies. You should do something about your allergies, or if you're morbidly obese, but I'm talking about nobody can change that rate until we can't do this, because metabolism is inordinately complex. We are sufficiently well built. Nobody is experimenting on an elephant for longevity genes because they're brilliantly built. All we do is pick species like mice or worms or flies that don't have this, then tweak that and say, voila, we're done. Because we'll just implement that in human. It doesn't work. It doesn't work. We spend a large time building our bodies, and for that we are doing fantastically well. Dealing with the products of damage, well, if you've ever used our medical system, you know already that we are great at this. Bandages, antiseptics, waiting 3 months for x-rays, whatever. All of that is as good as we can get currently. Techniques will improve. There will be more technology, especially from the Bay Area, that will give you apps to do this better. But essentially, you'll be riding that roller coaster that I said. It's not going to help you. The only thing in the short term, this will help, by the way, but that's long term. In the short term, the only thing that can help is that technology. The drugs that are coming out to help Alzheimer's tangles may help. I don't know. They have to go on clinical trials to see if they do. But cleaning up damage generated by metabolism does help. This is a summary paper. This is the penultimate slide that came out last year. This summarizes everything that we think are the damages of metabolism. There is junk inside cell, there is junk outside cell. There are mutations inside the nucleus, there are mutations outside the nucleus, there are too few cells, there are too many cells, and there is garbage that make the collagen and other things kind of bunch up together. That's it. Those are the 9-ish damages that are happening in the body. We now have a consensus